Hello guys, welcome to this session on Introduction to Number Theory by the Coding Culture. This is Manav Sinha, TSC lead from IMS Engineering College. Today we are going to discuss some topics related to number theory and solve a couple of problems related to them. So without any further delay, let's get started. First of all, I would like you to tell some of the topics which are frequently used in solving problems, especially in competitive programming. These are first, sieve of Eretus themes. This is used to find a list of prime numbers in a range from 1 to given number n. Second algorithm is prime factorization using sieve. This is a variant of sieve which is a very efficient way of factorizing a number. Next is, this is a famous one, Euclidean algorithm for GCD. This algorithm is used to find GCD of two given numbers. Next is matrix exponentiation. In this algorithm, as the name suggests, we find exponent to a matrix. Recurrence relations. This involves algorithms for solving recurrence relations. One of the most popular recurrence relation is Fibonacci sequence. You have heard about it, aren't you? And Chinese remainder theorem. This is also a very important algorithm which is useful in competitive programming. There are many such algorithms which are used, but these are some common ones. So let's get to next slide. How to approach the solution. So when you are beginner, we get sometimes overwhelmed by the amount of information we are given in a question. So how should we approach a problem to a solution? First, analyze the problem statement. You need to analyze the problem statement correctly. For this, you have to read it at least 2 to 3 times. It is very important to read the problem statement to understand it completely. This is very important step. Second, whatever you understood by the reading the problem statement, verify it with the sample test cases. That means verify it with the sample input and output so that you are ensured that you are on right track of solving that problem. Check constant. Checking constant is a very important step. Most of us make a mistake by not checking constant and directly try to solve the problem. But it's not a correct approach because as we know, there are many solutions to one particular problem, but we need to give a solution which is efficient enough to go with the given constraints. So just before you start to code solution for your problem, you need to check input and output format for that given problem so that you know how the input will be given for that problem and how you have to format that solution. After following all these steps, you are good to go for coding. There is a very nice quote given by Betty Williams that is, there's no use talking about the problems unless you talk about the solution. So enough of talk already. Let's go to our first problem. The first problem we are going to solve today is GCD queries. In this problem, we will be given an array A of size n. We will also given queries key. Each query is represented by two integers L and R. Corresponding to each query, we have to output the GCD of whole array, excluding the elements from index L to index R. So now, before starting the algorithm for this solution for this problem, I would like you to tell about Euclidean algorithm for GCD. Euclidean algorithm for GCD is stated as to find out GCD of two numbers, say A and B, it is given as A if the second element B is equal to 0. Otherwise, we recursively use this formula where we call GCD with B comma A mod B if B is not equal to 0. So let's understand this by taking an example. Here we are trying to find out the GCD of two numbers that are 18 and 14. So since we know that if the second element is not equals to 0, we have to recursively call this function with this as this. So we have to call this like this GCD of 14 comma 18 mod 14, which is nothing but equal to GCD 14 comma 4. Again, the second element is still not equal to 0. So we have to recursively call this function using this formula, which becomes GCD of 4 comma 14 mod 4, which becomes equals to GCD 4 comma 2. Again, we see that B is still not equals to 0. So again, we call that recursive formula, that is GCD, that becomes GCD 2 comma 4 mod 2 equals to GCD 2 comma 0. This time we notice that the second element becomes 0. And from the formula we know that when the second element of two elements we are finding GCD is equal to 0, the GCD becomes the first element. So GCD for 18 comma 14 becomes 2. Now in this problem we are given, let's check the test case input format for this problem. In the input format for this problem is as follows. The first line of each test case contains a single integer t which denotes the number of test cases we have to answer. The first line of each test case contains two numbers n and q which denotes the number of elements in that array, and q denotes the number of queries we have to answer. The next line contains n space separated integers denoting the number of elements of array. Now the next q lines of each test cases contains q queries in which each query is represented by two integers l and r. Now let's look at the sample test case. In the sample test case, for first line is given as 1, which denotes the number of test cases. Therefore, t equals to 1 is this case. Now, for the next line of each test cases, as given in the input format, contains two integer n and q. N denotes the number of elements in that array we have to answer the queries, and q denotes the number of queries we have to answer in that test case. So now, next line of each test case as given are n space separated integer. In this case, 3 space separated integer denoting the elements of array. That is array for this test case is 269. Now in subsequent lines, q lines denotes each query denoted by two integers l and r. We have to corresponding to each query, we have to give the GCD of whole array excluding the elements at index range from L to R. Note that it was given in question the array in this problem will be 1 based, not 0 based. That is, indexing will start from 1. So we have to exclude all the elements which are in range L to R and then find GCD. For the first query, that is L is given as 1 and R equals to 1. That is, we have to only exclude first element, that is 2, and find the GCD of other elements 6 and 9. So we have to find the GCD of 6 and 9 excluding 2 and output it. So GCD of 6 and 9 is 3. That's what we have outputted. Similarly, for the second query, L and R are given again equal 2. So we have to ignore the second element of that array, that is 6, and find the GCD of all the other elements, that is 2 and 9. So the GCD becomes 1 for given query. For the next query, we are given two index 2 and 3. That is, value of L is given as 2 and value of R is given as 3. So we have to remove all the elements of, not remove, but exclude all the elements from index 2 to 3 of the given array and then find the GCD of remaining. So in this array, at index 2 is 6 and index 3 is 9. So we have to find GCD of only a single element, that will be 2. That was a test case. We have to now look at the constants. The constants are given as follows, that n and t can be in the range between 1 to 10 raised to the power 5. Similarly, q can be in range 1 to 10 raised to the power 5. Each element of an array can range between 1 to 10 raised to the power 5. Also, L and R, which denotes each query, can be anything between 1 and n. As you can see, the constants are pretty big for this problem. So it won't be easy to solve the problem in limited time. So we have to think of an efficient algorithm to solve this problem. The naive approach is that we find the GCD every time for each query, excluding the elements which are in range L to R. But since constants are big enough, this won't be efficient enough for this problem. So how we can approach the problem? Let's take an example. We have taken an array 24, 30, 18, 42, 28 and 14. And L, let's take L equals to 3 and R equals to 4. So we have to, according to the problem, we have to find the solution of GCD of 24, 30, 28 and 14. So this can be breakdown as GCD of 24, 13, GCD of 28, 14 and taking GCD of both these numbers. So basically we are taking GCD of numbers before L, that is before L up to L minus 1, that is 2, and after R, that is from R plus 1 to N, that is from 5 to N, that is 6 for this case. So basically we are taking GCD of all the elements before the range and after the range, which is equals to GCD of 6, 14 equals to 2. This approach seems good as we don't have to calculate GCD again and again if we find some solution in which we can store the GCD of all elements of all elements in array up to a particular index some other way. Similarly, we need to store all the GCDs of the elements of array from backward to front as well. For this, we will create two arrays. First is prefix, in which for each index I, we will store first value. At first index, we will store each GCD of all values from 1 to 1. That is 20. Since GCD of one element is 24, one element is itself, so we will store 24. Similarly, for the second index, we will store all the values from first element to second element in this index. So GCD, we will at the second index of prefix array, we are going to store GCD of first two element, that is 24 comma 30. The GCD of 24 comma 30 is 6. Similarly, we will store the GCD of first three element 24, 30, 18 in the third element of the prefix array. So now at the GCD of first four element will be stored at the four index of the prefix array. Similarly, we will fill the complete prefix array by filling GCD of first five values in the fifth position and GCD of all the elements in the last position. We will know from this index of this array that what GCD we have for elements up to particular index. Similarly, for suffix array, we will start from backward. We will store the last GCD of only last element in the last index. Then we will store the GCD of last two elements in the second last index of that suffix array. Similarly, we will store GCD of last three elements, that is 42, 28, and 14 in the n minus 3 index of suffix array. In this way, we will completely fill the suffix array so that we can use this result of these two arrays later was by answering the queries. For this solution, as I discussed earlier, to find GCD of all elements of an array excluding the elements at range L and R, we can directly use the formula GCD of prefix of L minus 1 comma suffix of R plus 1. In this way, we are really using a lot of this is a very efficient way rather than naive approach of finding GCD for each query of each element by excluding the elements from range L to R. Now let's code for this solution of the GCD queue. First, we have to write function for finding GCD of two numbers using including algorithm. As algorithm states, if b double equals to 0, the GCD of two numbers becomes A. Else we will recursively call the function return GCD of b comma A mod b. So this is the function to recur. Now in the main function, this is used to redirect input output so that it becomes easy to check for input output. This is used for fast IO, and I have handled test cases here. For each test cases, we will be calling solve function, which we will be handling each test cases. Now let's solve for each test case. For each test case, first line consists of two integers n and q. So first, let's take input them. Now we have to initialize an array of LL. Here LL means long. I have already renamed it by using type def to LL so that it becomes easier to write. So LL A of size max, where I have defined max to be size of around 10 raised to the 5, which was maximum given constant for the length of array. So now we will need to take input of that array for Now we need to prepare two arrays, prefix and suffix array, that stores value of GCDs of each of elements of array up to a particular index. Prefix stores from front to back and suffix stores back to front. So let's define two array again with the max SF. First of all, we need to initialize each element in this array to 0. SF Now let's create prefix. Let's prepare the prefix array. This statement here will create a prefix array which will be storing GCDs of each element up to ith index of in this prefix array. This will is creating suffix array which will be storing from backwards to front the GCDs of all elements of the array A at index n minus I. Now we have to answer QA queries. So for that, for each query, first we have to input two numbers L and R. Now the answer for this, as discussed in the approach, will be GCD of prefix I plus 1, sorry, L minus 1, comma, SF R plus 1. Also after. Now let's check if it's working or not. Okay. Six, 1, 2. The answer for first is not correct. Let's check why. Okay. Here we need, because we are going backwards to frontward, we need to solve it using plus 1. So we will go into backward frontward. Here we need to do this. I think yes. So our answer is correct. Now let's check the answer if it's working or not on the code check. Yep, it is accepted. So in this course problem, you understood how we can solve a problem with large constant in an efficient manner. Now we will solve another question which is from Codeforces. This problem is called numbers into sequence. In this problem, we will be given an integer n. Our task is to find a sequence of integers such that each element of the sequence is greater than 1. The product of each element of sequence is equal to n, that is number itself. Also, If the sequence is of suppose say 4 numbers, that is A1, A2, A3, A4, A2 should be divisible by A1, A3 should be divisible by A2, and A4 should be divisible by A3. Basically, this means that all of the elements in the sequence should have at least one common divisor. Also, we have to find this sequence such that then there are maximum possible number of elements in that sequence. So now let us take a look at input format of this question. In this question, in the first line of input, we would be given an integer t denoting the number of test cases. And for each test cases, we would be given a single integer n. The constants for that of this problem are t can be anywhere between 1 to 5000, and n, the number which we have to break into sequence, can be anywhere between 2 to 10 to the power 10. Note that we have to keep in mind that we have to store this number in a variable that is large enough to store a number of range 10 to the power 10. So let us see how we can approach this problem. First, we will look into test cases. For example, in this sample test case, we are given 4 test cases. For first test cases, n is equals to 2. For each test cases, we have to output number of elements we got in the sequence after breaking it. Since 2 is a prime, we cannot break it any further, so we can only get one number for breaking it into it, so 2. Similarly, for 360, it can be broken down into 3 numbers such that 2, 2 to 90, and each successive number is divisible by its divisor. That is, 90 is divisible by 2 and 2 is divisible by 2. So it is acceptable answer. Similarly, for number 411197, it could be this number. It could be broken down only into one number, that is itself. So how do we now write the answer? We know that there can be at most 3 factors of that of in which 360 can be broken down. So we initialize an array of length n, of length 3. We completely factorize the prime number and find frequency of each unique factor. So there could be 3 cases. Case 1, when n is prime. If n is prime, for example 2, there will be only one factor of it. So solution will be given by 1, that is number of elements we break down it into, and second, the number we break down into. So in this case, solution will be 1, that is the number of elements in that sequence, and that sequence, that is 2. The maximum frequency of each factor is 1. For example, let's take a number 30. 30 can be factorized as 2 into 3 into 5. We cannot break it into sequence such that each number is divisible by its predecessor. For example, when we have common, because there are only 3 factors of 30, which we cannot duplicate them. So only possible answer in this case will be again 30. But what if the maximum frequency of a factor of a number is greater than 1? For example, in case of 360, as we have seen in test case, it can be factorized into 2 into 2 into 2 into 3 into 3 into 5, where frequency of 2 is 3, frequency of 3 is given as 2, and frequency of 5 is 1. So we have at least one factor whose frequency is greater than 1. So what will be the answer in this solution? From the problem statement, we know that each element of the sequence should have at least one common factor. So since here 2 has the maximum frequency, the maximum number of elements which are possible in that sequence would be 3, because it can only be put into 3 sequence to break it down. Initialize 1 to n minus 1 element of that given sequence with the factor having maximum frequency, and the last element could be given as n divided by a1, a2 up to an minus 1. So now let's start coding for the given problem. As I have said earlier, I have used input output redirection to easily check the test cases, fast IO for easy computation of 8 online judges, and I handle the input test cases. For each test cases, we are going to call solve function, so that where we will be handling all test cases. For each test cases, we will be given an input of just one value, that is n. So let's take input of n. Here ULL defines for unsigned long edge, since The constant for n was 10 raised to the power 10, so we need to use ull dart type. Let's also make a copy of n at a variable k. Now we need to find the factor with highest frequency for n. So let's first initialize max frequency to take record of maximum frequency and factor with highest frequency equals to, let's take n for initialization. Now we will be checking for factors of n from 2 to its square root, so that we have a complexity of around square root of n basically. So let's start while while to check to key frequency of each variable, we are defining a local variable inside the for loop which will keep frequency of each, basically I at that point. This loop basically stores I is a factor of n, then it stores the frequency of I and number of time for each of the values of I. So if this frequency is greater than max frequency, then max frequency will become equals to frequency. Also we will store the value of I in the fact I equals to I. Now as discussed earlier, if max frequency is double equals to 1, that means there is no factor of n which have more than one frequency, then we know that solution will be equal only one element in sequences. We cannot break down that sequence and it will be or the number itself. Remember we stored the duplicate of number n in variable k because we were here finding, we actually destroyed the original n value by factorizing it. But if the maximum frequency is not 1, then we can break down the number exactly into max frequency count. So first we will print max frequency, then for up to n minus 1, for 1 to n minus 1, basically we will print out, to make it simpler, as I said, to 1 to max frequency minus 1, we will print out the factor with maximum frequency and divide k with that, with the maximum frequency, with the factor with highest frequency. So first of all we need to see out factor high, give a space, also divide k with equals to factor high, so that we can get out the value at the last index k. This was the sample test case which was given to us in the problem, so I think it should work. Let's try it out. Okay, we just need to proceed out. For each, after each case test, we need to print end line. Okay, I think it works. So we can, I think this could be similarly this could be. So we are now warning free. So now let's check if this problem, if this code works or not. Again, submit code. It was problem D. Good. Control paste. Think it should work. Yes, it is accepted. So there are many problems related to number theory, as two of them discussed today. You can solve more and more problems to get solution, to get practice and get actually type of kind of expertise in the number theory. We will be providing you many resources in the Discord server as well. So thank you for tuning in. Happy coding. Hello guys, I hope you have enjoyed the video. There are many problems related to number theory which you can solve to get expertise in this problems. Basically, I solved two of the problems based on GCD, and one was based on prime factorization. These two problems were uh, put down in two contests, in Code Forces and Code Chef. Basically, there are many things which we can do to get expertise in this type of problems on number theory. So one of the question was asked that how to develop mathematical thinking. The we can actually use very much questions. For mathematical thinking, the main thing is that how you can solve more and more questions and develop it. It's not a one-day process. You have to solve it regularly. You have to solve problems regularly and regularly. For my experience, uh, what I have experienced that mathematical thinking is something like when you solve more and problems related to number theory and mathematical concepts, you problems you develop a thinking where you can solve it easily. Striking problem, understanding a problem is really main thing in this. There are many mathematical concepts which you can use in a problem, but sometimes it is very twisted and twisted like so that you get confused. The only thing which can help this is solving more and problems on which different sides. I think that should answer the question that how you can generate mathematical thinking. This is there are many concepts like GCDs, prime factorizations, which are used. Chinese remainder theorem, modular arithmetic. It's a very good topic. When I was learning number theory, uh, there are many interesting topics which came. Sieve of ellipses. When I first learned sieve, it was one of the very interesting topic I got because you can solve for prime numbers of higher orders, that is 10 raised to a power 2, you can solve it in very efficient manner. Similarly, there are many other algorithms like you say one is variant of C, that is, yeah, finding prime factorization by C. You can find up to order of 10 to the power 6 prime factorization around, I think, log of n, if I'm not wrong. So there are many things you can use for solving problems, mathematical thinking. Uh, I think that answers the questions.
That was a great answer, Manav. And that was a great session. Truly, that was really, really great. I hope the audience enjoyed as much as I did. Moving on to the next question, Manav. The next question is how to hunt for edge cases. There's also a problem that I keep facing when I do competitive programming, and I really need your advice on this.
What from my experience, what I do is try to first main thing, as I said, that check constants first, because whenever you need to hunt for test for edge cases, you need to check the best constant in the given question, because sometimes what we happen is we try to solve the problem just after reading the problem statement and what seeing the sample test cases. But if you check the constants, first of all, try to see what are the first two test cases, basic that is limit, sorry, limits of that concept. For example, if n is from 1 to 10 to 10 raised to the power 5, try to think that what would be the answer for that, and then use data structures, apply data structure which would fit in the for that constant, so that you can answer the problem. This is the way how you will try to answer the edge cases. One of as you go on to solve more and more question, this will become very very effective for you. You will not need to hunt for solve for test cases separately, but initially I think best practice is to solve it separately using pen paper, then go on and solve. Checking constant is one of the most important thing for any problem.
Thank you so much, Manav. I think that does answer the question. Moving on to the next question, how to optimize the code.
Yep, that's an interesting one. Basically, if you want to optimize code, you have to practice a lot. For example, like sorting can be done in n square for basic sorts like selection sorts, bubble sort, etc. But there are many algorithms which are like merge sort, quick sort, which can sort a problem in n log n, sort array in n log n. So you have to think about different ways to solve a problem. Not always there will be a sort optimization which could you can or you can apply in that algorithm, but you have to think about different approach you can solve that. Optimization is one of the things you will learn by exploring different libraries. For example, there is a sort function which is available in C++ STL, which directly gives you a best complexity sorting in C++. So optimization is something like that. For one of the most efficient practice which I have found really useful is up solving the problem by seeing a tutorial of each contest. It is a really a greatest treasure because for example, you have given a contest on code forces, you were able to solve two problems. For third problem, you were stuck in due to a TLE, that is time limit exceeded. You thought that your logic was right, but there was something. When you see that tutorial, you will always see a better approach from your approach that would help you to understand that there are many approaches which we can use to solve a problem. Similarly, for from my experience, I said once I tried when I get to code chef, I solved a problem in order of 2 raised to the power n. I thought it was really good solution, but when I tested it out, posted the solution, it given a clearly in the two later subtasks, subtask 2 and subtask 3. When I gone through the algorithm, they have solved the algorithm in around O of n, which was really fantastic. That bringing down an algorithm of complexity O of 2n to O of n is really a difficult job. You will learn solving different type of problems in less complexity as you try different problems and approach and see their approach by different coders. You have to see codes of different good coders, pro coders, like code whenever you participate in contests like Google Kickstart, Google Code Gem. There are many coders who solve all the problems. We are not able to do so, but when you see their approach of solving each problem, you will see that what is the difference between our code and your code, their code and our code, because algorithms they use are really optimized. Plus, they have a very good practice on different problems on different approaches. I think one of the best part is that competitive programming is like a sport. You have to turn up daily, practice daily, but you will only get experience when you turn up on different contests on the regular basis. I think that's one of the advice I would like to give, that take competitive programming as a sports, that you daily participate in contests, regularly turn up to solve problems, so that you basically develop thinking where you can solve different approaches. Take it as a challenge, not as a task. When you start taking it as a challenge, you will find it very good to how satisfying it is to solve a problem. If you are taking it as a task, you will think that okay, I'm not able to solve it, but I will somehow. But when you take yourself up to a challenge for solving every contest in every question, it will feel satisfied when you have accomplished it. So that's how I have also motivated myself.
That was great advice, Manav. Truly. I hope the audience will listen to your advice and take note. Moving on to the next question. Which matters more in competitive programming, time complexity or space complexity?
Again, it depends on concept. In some problems, they will give you more of space than the time. But what I have seen from the questions, time complexity is one that prevails over space complexity, because we will at most time we will have enough space to apply algorithm. But time complexity, if you can improve on that for every problem, your performance in every contest will improve. So, in my opinion, time complexity prevails over space complexity in various contests which take place around internet.
Thank you so much, Manav. Okay, moving on to the last question of today. Okay, we have another question. What is the use of GCD?
Yeah, GCD is basically greatest common divisor. It is a very important type of algorithm which is basically used in many questions on contest, because it's GCD is basically highest common factor of two numbers. Use of GCD, basically it is a mathematical concept which is used to trick us in the various problem for solving. You use you can have it. It is used in various type of mathematical models, etc. I think basic main importance of these type of algorithm like GCD is to have good questions in the competitive programming, so that we can have a mathematical type kind of develop mathematical kind of thinking, so that we can solve this problem.
That was great, Manav. There's another question, and I think they're looking for advice from you. So someone said that they're doing CP from the last 6 months, but he's not seeing they're not seeing any improvement in themselves, and then reaching out to you for help and advice.
This is something I also faced. What I was lacking is that I was not up solving problems after contest. I participated in each contest. How many I was able to solve one or two, but after the contest and editorials come out, I was not up solving the problems with the given editor of the editorials that came out. It Because you can, when you are solving the problems which you are not growing, your growth is none. But when you are seeing different type of problems which you cannot solve, but uh, you are basically up solving them using editorials, you will learn algorithm. At least if you solve only one problem for each contest, you will be learning one new algorithm for each contest, which will be helpful for you afterward. In this way, there is a steady growth in your performance. I have also experienced the same problem in first few 5-6 months, and then I think when I started up solving the problems, I got a significant improvement in my performance. So my advice is to up solve problems in each contest, so that you can understand various algorithms which can be used to approach problems in different contests.
Thank you so much, Manav. That was actually great advice. I hope all of us are able to note it, from your experience, and we take your advice. So, guys, we have a surprise for all of you. Tomorrow, we have scheduled a keynote session on number theory and mathematics. It is my pleasure and an immense honor for me to introduce the speaker for tomorrow. The speaker is Muhammad Nizamuddin Farhan. He is a candidate master at Codeforces and an upcoming SD intern at Amazon. Not only this, but he's also an ACM ICPC regionalist. Let us hear a little about the speaker from the speaker himself. I will be sharing my screen. One second.
Hello everyone, hope you all are doing great. I'm Nizamuddin Farhan, I'm rated candidate master at Codeforces, and I'll be joining as SD intern at Amazon this January. I'm really excited for tomorrow's webinar. Watch me speak tomorrow on number theory. Take care, goodbye.
Please utilize this opportunity that we've provided for tomorrow and prepare the questions that you would like to ask the speaker or the advice that you would like to get from him. We're also going to circulate a form right now in which you can post questions that you would like to ask the speaker. The form will be posted in the discussion in the discussion in the YouTube live chat. That's about it from us, guys. If you have further questions, please join our Discord group and please ask your questions in Discord. That's it. Thank you for tuning in. Hope to see you tomorrow.